guys, welcome to the shop. This week it's grinder time. I'm going to be tearing down this grinder. I make pretty good progress on it, I think. I've spent more time than I should on it, but you know, I am making good progress, let's just say that. We work on that. I got some welding that I'll show you. I got some viewer mail. I've got a small shaper demonstration. I got a few things, so let's get started. Well, I think that I'm ready to pull the table off this thing. I got pretty much stripped down, I think. Both of the spark guards off. I got the rack unbolted and took the handle off. The rack doesn't necessarily look bad, so that's good. Probably wasn't used that much where it's automatic, but we'll clean it up anyway. It's about as basic as it gets. 2 screws. Got everything off that was in the way. Also unhooked the hydraulic cylinder that runs underneath the table. So I'm pretty sure that that's it. So I'm gonna lift it off here. And I'm kind of excited to see what's under there. Hopefully it's good. Well, let me get this thing down and flipped up, and I'll get you a good shot in there. Well, here is underneath the table. Pretty crusty, really, but you know, it's not as bad as it could be, I guess. We got 2 rows of balls here. Those balls are captured with some sort of plastic, strips with holes in it, just to keep them all evenly spaced. You know, not as dirty as what I was really expecting, to be honest. You know, we got a large or long hydraulic cylinder here. This is the that moves the table, and all it does is bolt on the ends of the table with 2 bolts on each side. It's really, you know, not a lot of pressure involved in moving this table back and forth. So pretty simple. You know, I don't know if any of you guys had seen underneath one of these before, but you know, I'm just going to pull these out and clean them. I'm going to clean everything that I can see before I tear down this thing any farther, and you know, assess its condition just visually, and maybe precision stone these if I can. So I'm going to dig in here, I guess. I guess I was a little surprised, you know, that there's grease. It's just some sort of grease that's on these balls. I don't know how good of an idea, you know, grease is on a grinder. Always the dirtiest on the ends. Stuff gets pulled up, you know, dust gets up and under the table, and always gets them at the ends. The grinder would last, I think, a really long time if it was shielded properly, but most of them are not. It's just the minimum That's what it seems. So about an hour in, and that actually cleaned up pretty good. I'm not seeing anything that concerns me, but that doesn't mean much. But everything looks okay. I'm not seeing any dents or anything in the channels here where the balls ride. But the only thing will tell as far as their condition is using the thing. But visually they look good, so that's promising. Alright, so I brought the balls and tracks outside. I wanted to be able to see good. And the only way to ensure that these get really clean is to clean each, pop them out of the holder and wash, each ball individually and just in some kerosene, just a preliminary cleaning. I'll come back and clean them again, but put them in the thing and do each one, then clean the holders really well. Otherwise, you just can't get out around these without pulling them out. And these holders, they're segmented, so they pop apart ever so often. Alright, so I got the table flipped upside down, leaning up against the mill here, and I want to wipe off these ways and look at them. They're kind of my main concern. I don't know that they necessarily should be, but they seem to be the most susceptible. The tableways seem to be the most susceptible to damage with transport, and that's one of my main concerns. So we're going to take a good look at those, and I'll get you untied on them. But cleaned up the balls and the holders, and they're about what I would expect. Definitely probably should be replaced. A lot of the balls have lost their shine, and they've got some wear on them, of course. And if everything else turns out good, I may consider putting some new balls in it. I don't know if you should do that with the ways, but because if they're worn, the ways are worn. Some, whether it's to an extent that'll make any difference, I don't know that, but we will find out. That is for sure. But first, I just want to wipe off these ways and look at them. So let me get you in close and get you a shot of them. All right, so here is the ways. I wiped them all off. I don't necessarily know what to say. I mean, you can see where the balls run, but I'm not seeing any divots, which is good. There's a couple little spots, one right up here, but nothing looks horrible. Let's just say that. It's hard to tell when you're dealing with surfaces like this, but I'm not seeing any any valleys or anything like that. No excessively worn area, relative to the next. So, all we can do is try it. But I'm surprised. Let's just say that it's not worse than it is, given the condition of the grinder. So I think this gives me some hope. All we can do is try. What are you doing, girl? What are you doing?
Get up there, boy.
So I'm taking out the last bolt here, and the bolts that I'm taking out are for the nut for the Z-axis for the saddle here, and that and one oil line that goes to the nut is the only thing that connects this saddle to the actual main casting. So not much other than gravity really holds this thing together, and we'll see what's under here. It's pretty dirty, but who knows? I see some corrosion, on these on the ways, but we'll just have to get a good look. I'll have to strap this thing up and lift it off. I bet it's going to be pretty heavy, really. And that is heavy. Picked it up nice though, nice and level. Should be pretty easy to get back on. Alright, so looks like somebody may have replaced this electric motor that runs the Z-axis at one time. It had some electrical tape and wire nuts on it. Well, I've got this saddle strung up here, and I've been cleaning up under it. Nothing special. It was definitely dirty, but nothing crazy. And the lead screw for the Z-axis has definitely got some wear on it. Everything's got some wear on it. It's a 1980s cheap grinder that probably wasn't cared for well. But this way it looks pretty good, actually. I can still see all the flaking marks on both sides down the entire length. This way here has had some water damage or coolant damage, I believe. I'll show you. And then I'll show you the main casting over here. I already somewhat cleaned up one side, but I left one side to show you what you can expect and what you should probably avoid if you go to, if you go to buy a grinder. Man, you better look close is all I got to say. And take your time. Don't just buy the first one that comes around. Because, in their nature, they deal with abrasive particles. So they wear horribly if they're not kept meticulously clean. And you should go out to your shop right now and apologize to your grinder if you haven't cleaned it recently. Let me bring you over here. Let me show you what we got, and then I'll explain to you my plans. Alright, so here's a better look under the saddle. It's got a fairly hefty nut here that is oiled, which is good if anyone would ever oil them. So, got some wear, of course, in the middle of the screw here. You can see that the tops of the Acme thread are sharper than, both ends. The typical wear on screw there. There's the electric motor, and that powers the drive here. It's just got a belt. The valve body that controls the speed of the back and forth of the table or side to side. And I'm getting it fairly clean. I still got probably about an hour to go. I've been working on this for probably about 3 hours. So it's got a lot of pockets and stuff up in here that held a lot of abrasive material, and it rains down into these V-ways and causes quite a bit of wear. Let me get this spun around here and get you zoomed in on this way that has the most damage. Alright, so here is absolutely the worst part of the saddle. And you can see it has long score lines from abrasive material getting on the way. Now the other side of this is not that bad. I mean, it's not good, but it's not near this bad. And I can see a lot of pitting on this, and there's a lot of rusty colored oil in the V over there. So it's had water or moisture in this side at one time, probably from, this is the coolant drain. It's probably splashing right here into this V-way. That's just an assumption, and caused a lot of wear on this side. Who knows? I'm going to stone this really good, clean it, and put this baby back together and let her ride. That's kind of the plan. But still got a lot of cleaning to do. But it's definitely getting close. Let me take you over and show you the main casting. All right, here's a quick look. I already started to clean the other side up. The whole bottom of the grinder looked basically like this. It looked like all old grinders that have had a cold supper. But I'm gonna clean it up and see what we got. These ways are actually turkited on both sides, so a person could, if they wanted to, strip this turkite out and re-scrape this casting in, and basically the casting would be fine. But even if you did that, you'd still have a $300 grinder and $1,000 worth of labor in it. So, we're just going to clean it up and see how she grinds. I'm interested to see. Looks like they done a minimal job on this thing. Either that or that's, some corrosion in there. But, yeah, and I also got an oil line here that's got a hole rubbed in it, so I had to repair that too. Repair that, repair this, and blow out, these way oil holes. Not a big deal. It has to be done. Yeah, those will have to be flushed with kerosene. You just can't trust, you can't trust them. Once they've had debris in here, it gets down in the oil passages, and then when you pump oil in it, your clean surfaces now have grinding grit on them. Look what came out of this one. This side's pretty bad. Alright, so we are into day number 3 on this surface grinder teardown and clean. And, everything needs attention on that. It's not, nothing can be left really alone. Not for me anyway. The wheel that was on it, this is the hub that was on it, and this is the wheel that was on it, is a NordPro, it's a Norton 60H high porosity grind wheel. I had to take this stuff off to clean the hub and to check this wheel. I ended up putting another wheel on it, but this one looks like it's had some oil on it, and I don't like that, but anyway. Ring's good, so it probably would have been plenty safe to use as long as it, was in balance. But I put this one on there. It's a fairly clean, used wheel, but I think it'll be fine. So this hub, you can see these 3 weights. That's a but a balancing hub. You can move these 3 weights around in order to balance your wheel. Now, my cutter grinder does not have balancing hubs on it, so I have to use a different method to balance them. And what I do, and I guess it could be a controversial method, but a lot of people do it and it works, is I just use a carbide drill and remove weight on the high side. And it's an effective way, and as long as you don't get carried away and really compromise the integrity of the wheel severely. It works fine. It has for me anyway, and for a lot of others. I think there is some epoxy and stuff that you can use, but this works, and that's what I do on my cutter grinder. I ended up making the nut or the bolt that holds the grinding wheel to the spindle. It ended up being a 12 millimeter by 1.5 left-handed, and I spun this out at work on my lunch hour on our Summit lathe because it has the gearing and stuff where I can turn metric threads. Turned out really nice, and I just spun it out of a large grade 8 bolt because it's what I had. And I've already test fit it, and I think it'll be fine. Just spun a hex on it too. I didn't spin it on there, milled it on there. Anyway, let me get you down here. I'm going to show you a little about these hubs because I was kind of surprised at the way that they work. It wasn't what I originally thought in my mind. So let me get you down here and show you. Alright, so I've got my wheel on a balancer here. This is actually a prop balancer from RC airplanes, and it's a really sensitive little unit. And you can see the 3 weights here, and I've got them pretty much balanced. And the way that I do it, I do the same thing with a non-balancing hub. I just mark the wheel and go drill on the heavy side, but we just move weights around on these. But what I do is I just barely try to rotate the wheel. I can't control exactly how much I spin this wheel with my finger. It's a little different every time. But what I can see is the stop and then the rebound of the wheel. You can watch every time I spin it, it'll stop and then slightly bounce back. That bounce back is what I'm watching. I want it to be consistent all the way around. I don't want it to bounce back farther on one spin than the next. It's kind of hard to explain, but that's the way that I do it. I just tick the wheel around a little bit, watching for that rebound, and if I got a side that's heavy that's coming up, it'll rebound a little more, and then I just move my weights accordingly. So it's pretty basic the way that I do it, and it really works because you can definitely tell the difference between a bad out of balance wheel and a wheel that's properly balanced. Your finish, it shows. Alright, so these are the weights. Of course, I already showed those, but they don't actually work the way that I thought they do. There may be some out there that work the way I envisioned in my mind. I've never actually worked on one of these other than this one. So let me show you actually how they work. You got a little set screw here that locks the weight in place. But what I thought originally is that this set screw was angled, and that the weight was split, and when you screw this in, it spreads that weight out and locks it into its into the hub here. But that's actually not the case. There is a little ball in there that I'm sure that you probably can't even see, and maybe you can, a little shiny spot. Anyway, this set screw pushes that ball out against the outside of the hub and locks the weight in place. So I thought that was pretty neat, and I was a bit surprised that it didn't work the way that I thought they did in my mind. And I just want to say a big thank you. I bet you 8 or 10 people email me and offer to make this bolt for me. And I just want to say a big thank you to all the guys who did. And this is part of the enjoyment. I like doing these projects in order to make this kind of stuff. It makes me a better machinist to have to make them. I mean, there's nothing special about a left-handed thread. I've turned a bunch of those, and I just don't work in metric a lot, but it's just numbers, so not that hard. But you get the deal. I enjoy making this stuff, and really appreciate the offers from the guys who did. But it turned out really nice, as you can see. I did make it 3 thou under the minimum pitch diameter. It did it actually on accident. I was trying to hit the low side of it, but you know, because I wanted it to work the first time, I did not have anything to test fit this to. Actually, you know, wanted it to work the first time, so you know, we're not making a rocket ship. It fits good. It's just the slightest bit loose. Alright, so a couple weeks ago I said I would, you know, show this shear tool and how I got the finish that I get on aluminum. I can get some pretty good finishes with this tool, but strictly a finishing tool, you know, only a couple thousandths really. It's all you can pull off of it and expect a good finish, at least with this grind. But I need to rough this surface down first. And I'm just using a standard, you know, standard tool for that, and then we'll go to this and I'll show you, you know, the finish that I get and the chips that this thing makes, which are pretty unique, really. This tool, you know, works equally as well on steel, and it really holds up well as long as you keep plenty of lubrication on it. I'm just going to be using Tap Magic for my cutting lubrication, or my cutting fluid. So that, bring it a little closer. Okay, so not, well, my hands are filthy, but my gloves. But anyway, you know, that's 20 thousandths per step. Wow, that looks horrible. There we go. That's 20 thousandths per step. You know, it doesn't look that great. We're just using a, you can't see it. Standard, fairly decent radius there. You know, works fine and acceptable, but we can get this a whole lot better, and we'll change out to this. So, at least in my experience, shear tool is really picky. You don't want to start on an uneven surface where your chip load varies. So good smooth surface, then final stage, you know, will be your shear tool. Got to constantly keep the chips, you know, from getting under the cutter and from piling up. They're kind of hard to control. And when they're steel, this happens to be, of course, aluminum. They get in your hands and stuff really bad. take a look at this. Alright, so there is the finish that we just cut, and you know, it looks like it's got a bunch of ripples in it, but man, it's even hard to photo. But you know, here's another one that I done on this side. You know, no ripples in it. I think it's in the extrusion, but that is about as good as it gets, really. Yeah, I'm just not for sure what the deal is with that, but yeah, that is a pretty, well, it's hard to get a shot. It is a nice finish. Both of these done with the exact same tool, you know. Just, I don't know why this side came out looking like that. There it is. Alright, so here's our final pass. This is 310 stainless. Just a modification. This was a prefab, so none of this welding is mine, except for that. Just had to add a clean out. She's a little tough to get to in the back, so it's not quite as pretty back there. Perfectly acceptable. In my mind, anyway. It looks pretty good. Well, for the last 4 days, I have spent every waking moment that I've had available on this machine. I've cleaned every machine surface on it thoroughly. I cleaned the Z-axis screw. I cleaned completely under the saddle because it was really bad. If you've never cleaned up a grinder, man, that stuff is a nightmare to remove. Cleaned up the Z-axis screw and nut. Of course, cleaned and stoned the ways. Cleaned the table, ways, and balls on both the saddle and the table itself. Tore down the column on this thing. I didn't remove the spindle. I didn't want to mess with its alignment. But I cleaned its ways. I cleaned the screw. I cleaned the shields. I repaired and flushed the complete oil system on this thing. I have replaced a couple switch wires and you name it, I've done it. I made the spindle nut for this thing, cleaned the hub. That was 2 hours just to clean that hub. So I've done, you know, a respectable job on this, I think, for my intended purpose, which was to test function before I take this any farther, because you could spend a month on this easy And anybody who has ever cleaned up an old grinder probably gets that. This will be my third grinder that I've cleaned up, so I'm going to be putting this thing back together, and soon we're going to see how it grinds. I'm excited about it, to be honest. You know, just to see. There we go. Set on there. Alright, so I've got some viewer mail here that I want to share with you guys, and some really nice stuff. Some I've had for, you know, a few months and haven't showed. You know, just got to get around to it. I'm always out of time. This is the way it seems anyway. Mike Nixon sent me some really nice handmade, sent them to me in Elizabeth. My wife's name is Elizabeth. I know there's some confusion out there. And my wife's name is Elizabeth, but we call her Noelle. So anytime you hear me use either one of those names, I'm talking about my wife. So thank you. We've already used these, and you know, appreciate it. Really well made, belted on the back, nice little holder. I've seen Mike in the comments quite a bit. So thank you, Mike. I definitely appreciate it, and Elizabeth likes them also. So thank you. Sean contacted me. I don't have his last name. Contacted me over email and asked me if there was anything I could use from the KBC Tools sales catalog. Told me to pick something I wanted, and you know, that would help out the shop. And that, you know, greatly appreciated. It took me a while to figure out what I could get, and I wanted something that would give me the most bang for the buck. And looked around and decided on, wow, it's like a snake out of a can here. Decided on a Noga Mini Cool. Now, I've never used one of these, but from, you know, some of the other creators that have them and stuff, they seem to work fairly well. I have a shop-made unit, but it's a little finicky and could use some refinement. So I decided on one of these. This is something that I can use on all my machines. So thank you, Sean. I definitely appreciate it, and I definitely appreciate the offer for me to pick something I wanted, which was, you know, really nice. Definitely nice. Got some amazing viewers out there. So it's got these, you know, reinforced lines and stuff on it. Really well made unit. Noga makes definitely some good stuff. So thank you. Glenn Code sent me a 50 taper to threaded end, and I believe this is for a boring head. I think it will actually fit the boring head that I have, the small one, and eliminate me having to use it in a collet. So I really appreciate that. I'll just have to pull out this adapter here, and this should work perfectly fine. That and a shell mill. So thank you, Glenn. I definitely appreciate it. I've had that for, you know, a couple months. Same with these. I've had these for a while. These were sent to me by Earl Baumann. I'm butchering the last name, I'm sure. It's B-A-U-M-A-N-N, Earl. He sent me these two holders. One is a 5/8 and one is a 1/2 inch holder to 50 taper. I haven't cleaned them up yet. And he also sent a large face mill. So thank you, Earl. I definitely appreciate it. And I have a few other pieces of viewer mail that I haven't showed yet. Kim Code sent me some reamers, but I've already put them up, and digging through all my reamers to pick out each one to show you. You know, they were some reamers. I definitely appreciate it. Sent me a nice medallion. Kim, I believe, was a Border Patrol agent, so, or worked with the Border Patrol. So a really nice letter also. So thank you, Kim. I definitely appreciate it. So got a few other things, but we'll share those in the future. So thank you, guys. I definitely appreciate it. well, guys, fast forward another day, and you know, I set the table and stuff back on this, and got it pretty much hooked up and almost ready to do some tests on it. You know, I got to grind the chuck in, stuff like that. And I'm curious whether this thing will give me a good finish or not. You know, it's definitely got some wear in it, but you know, who knows? We'll see. That's all I can say. And I've done everything to this that I can think to do mechanically to get it into a position to where it doesn't further damage itself, because I definitely can't use a crunchy. And it will give me an accurate representation of how it's going to perform. Before I do anything cosmetic, you know, I want to know, you know, is it worth it? So we'll see, that's for sure. I've been welding up a small scoop. This is just the beginning for a spark collector. I got to have something to pull into my dust collector, you know, something right at the wheel. So I've been working on that. I've been working on a lot of things. So it's definitely been a busy, long week. So I think that's it. I got some machining I got to do next week. I got some paying jobs in the shop that I need to knock out. I've got, you know, a lot to do, let's just say that. So thanks for watching, guys. I definitely appreciate it. If you need anything, contact me, you know, through my email. Thanks to all my viewers, patrons, subscribers. You guys are awesome. I think that's it. See you next time, guys.